Happy New Year 2025. Wishing you all the best this year in your learning adventures. Shall we kick off the new year with a new focus? How about supersets? This versus that. We've got 3 sets of questions, 6 questions in total. Set 1, set 2, and set 3, where we'll be writing the primary trig ratios. The first column will be given an angle, and the second column will be given a point on the terminal arm. Here we go. Let's have a look at writing the primary trig ratios given an angle in standard position versus given a point on the terminal arm. Starting with 120 degrees, we can draw it on the coordinate plane, starting on the initial arm. So from the vertex, we have a line on the x-axis that's called the initial arm. To draw a positive angle, we go counterclockwise till we estimate about 120 degrees to the terminal arm. This is the angle 120 degrees in standard position. When we have an angle larger than 90 degrees, we can calculate the reference angle, drawing a dashed line always to the x-axis, forming a 90-degree angle. The reference angle can be calculated by subtracting 120 degrees from 180 degrees to find the missing angle here. And that would be, in this case, 60 degrees, which is very useful because we can rely on a special triangle called a 30, 60, 90 degree triangle where we know the lengths are 1, 2, and root 3 as shown. So if I clear this up a little bit, don't forget those names. Erase all that. And we'll just put the 60 degrees right here, the reference angle. Now across from 60 degrees, here in our special triangle, we have a length given as root 3. And in quadrant 2, which is where we're at, the vertical distance here, the y value, is root 3. Adjacent to 60 degrees is the length 1, but in quadrant 2, we would say that that distance is a -1, and then the hypotenuse in the special triangle becomes the radius of the circle formed on the grid. So there we have 1, 2, 3 side lengths for a 30, 60, 90 triangle, and we can write out the ratios. Remember our SOHCAHTOA? Well, it applies here as well, only this time the 60 degrees here is the angle we're looking at, and the side opposite is now called the y value. The side adjacent to the 60 degrees is now called the x value, and the side that's usually the hypotenuse now becomes r for radius of the circle. The sine of 120 degrees becomes the y over the r, opposite over hypotenuse, which is root 3 over 2. The cosine of 120 degrees is the x value over the r value, which is -1 over 2 in quadrant 2. And the tangent of 120 degrees is the y value over the x value, or the opposite over adjacent, which is root 3 over -1 or negative root 3. 3 primary trig ratios: sine, cosine, and tangent of 120 degrees. Great. Now let's compare a question where we're given a point on the terminal arm. We have 8, -6, and the terminal arm would be drawn here. So this time we're not in quadrant 2, we're in quadrant 4 because it goes 1, 2, 3, 4 counterclockwise. Now to find the reference angle here, we draw the dashed line to the x-axis to form that 90-degree angle, and the reference angle is shown right here. So we're not sure what it is, but we'll try to figure it out. And the angle in standard position actually is this whole entire counterclockwise turn. That would be right there. All right, so now we do have a y value, and we have an x value, and we have an r value. Can we figure out the lengths? Sure we can. I'm just going to erase a little bit of this and put the values in. Here's our reference angle once again. So the y value is going to be the -6, and the x value is going to be an 8. So we can definitely find our r value by using Pythagorean theorem because we have a right angle here. R is equal to the square root of 8 squared plus a -6 squared, which is the square root of 64 plus 36, which is kind of nice because it's 10. Our R value will be 10. We have the sine of the angle that we're not sure about is y over r, which is -6 over 10, which is -3 over 5 when we reduce it. The cosine of the angle is going to be x over r, which is 8 over 10, which is 4 over 5. And the tangent of the angle is going to be y over x, which is -6 over 8, which is -3 over 4. How could you find the angle measure? We'll take the inverse sine of -3 over 5. Second function sine, -3 divided by 5 equals 36.9. Let's see if the cosine matches that. Second function cosine, 4 divided by 5 is the ratio, 36.9 degrees. And let's try the inverse tangent of -3 divided by 4, and we get 36.9 degrees as well. The reference angle is 36.9 degrees, and in quadrant 4, the angle in standard position would be 360 degrees subtract 36.9 degrees, and we get 323.1 degrees. Before moving on, let's look at the steps. Start by drawing the angle, deciding on what quadrant the terminal arm lies, calculate the reference angle, use exact ratios from the special triangle if you can, if you've got a 30, 60, 45, and use x, y, and r values for the SOHCAHTOA to find the ratios. Versus when you're given a point, plot the point, decide what quadrant the terminal arm lies in, find the r using Pythagorean theorem, use the x, y, and r values for the SOHCAHTOA, and then finally you're able to figure out the angle in standard position using the reference angle. Second set of examples, here we have the angle 225, so we're going to go from the initial arm around to 180 and then a little bit more. So how much more do we go? Well, we could go 225 degrees subtract 180 degrees. 225 subtract 180. 45, which is a good thing because we can use the 45, 45, 90 degrees special triangle. When we draw the angle, we're going to go halfway right there to 45. So there's the 225. 45 is the reference angle right here. That's a 90 degree. The hypotenuse is root 2, or the r value, and the x value is going to be a -1 and a y value is going to be a -1. So we need to consider that. The sine of 225 degrees is going to be y over r, which is -1 over root 2. And we'll also rationalize, because we don't keep the root sign in the denominator, we'll have an answer of -√2 over 2 for our first primary trig ratio. The second one, the cosine of 225 degrees, is going to be x over r, which is -1 over root 2 again. Same answer, -√2 over 2. Lastly, we have the tangent of 225 degrees, which is going to be y over x, which is -1 over -1, which is 1. 3 primary trig ratios. Now let's compare that question with a different question when we're given a point, -8, -6. We are in quadrant 3 this time. So our y is -6 and our x is -8 and our reference angle is right there. The r value is the square root of -6 squared plus -8 squared, 10 again, and we only use the positive version for the r. And there we have it. We've got three values here for the sides. The sine of the angle is going to be the y value over the r value, which is -6/10 or -3/5. The cosine of the angle is the x/r, which is -8/10, -4/5, reduced. So now we can use the ratios to find the reference angle. We'll use the inverse sine of 3/5. You don't need to use the negative in there. You can just plug in the values to get the angle because we're dealing with the reference angle. 36.9 is the reference angle. But I want to check with the other two ratios just in case there was a mistake. We'll use the inverse cosine of 4 divided by 5, 36.9. And then we'll use the inverse tangent of 3 divided by 4, 36.9. Now we'll figure out the angle in standard position. Add 180, 216.9. 216.9 is our angle in quadrant 3. So we got that by adding 180 for the x-axis plus our reference angle. And there you go. Did we follow the correct steps given an angle? Well, let's see. First, we drew the angle in standard position. We decided on the quadrant and we figured out the reference angle. We used the special triangle to get the side lengths. We used the x, y, and r values to find the SOHCAHTOA. And the steps given a point, we plotted the point, we decided on the quadrant, we found the r value using Pythagorean theorem, and we used the x, y, r values for the SOHCAHTOA. And finally, when we're given a point, we don't know the angle, but we can figure it out using the inverse operations of sine, cosine, and tangent. And of course, we know the reference angle, and that's what we can use to find the angle in standard position. Good. Last one, we're given an angle where it's negative. We start on the initial arm, but this time we go clockwise. One rotation is 360. So we have a -360 we went. We use up 360. Then we've got another 150 to go in that direction. Add 90. And we have 60 more to go. So the reference angle becomes 30. Right there. We have a special triangle. We have 1, 2, √3. For a 30, 60, 90 triangle. So this time across from the 30 degrees, the 1 is actually a negative, and that's the y value. And the x value is going to be also a negative, and that's going to be a -√3. And the hypotenuse, so the r value, is a 2. We can write sine of -510 degrees is y over r, which is -1/2. The cosine of -510 is x over r, which is -√3/2. And finally, the tangent of -510 is y over x, which is -1/√3. And we'll rationalize, so that becomes a positive √3/3. Our 3 trig ratios, sine, cosine, and tangent of -510. When we're given a point, 6, 3, we are in quadrant 1.
the x value is 6 and the y value is 3. Pythagorean theorem can reveal the r. And we can write that as 9 times 5, which is 3 root 5. Sine of the angle is y over r, 3 over 3 root 5, times by root 5 over root 5 to rationalize, and 3's make 1, root 5 over 5 for the sine. The cosine of the angle is x over r, 6 over 3 root 5, rationalize, 6 root 5 over 3 times 5, which is a 2 root 5 over 5. And the last one is tangent of the angle, y over x, 3 over 6, 1 over 2. We have 1, 2, 3 trig ratios, sine, cosine, and tangent of that angle. And now can we find the angle? Let's erase this. And we'll figure out the angle by using the inverse operations, root 5 over 5. And then we'll test all of them just to make sure we didn't make any mistakes. Inverse sine root 5 divided by 5. Hope I got that right. 26.6 for the reference angle. Second function, double brackets, 2 square root 5, move it over, divided by 5, close my bracket, equals 26.6. And then the last one we'll do tangent, inverse tangent. This one's an easy one, 3 divided by 6, 26.6. And where are we? We're in quadrant 1, so the reference angle is the angle in standard position. Great job. Let's review the steps. We drew the angle, we went clockwise 360 degrees and then some more. Which quadrant was in quadrant 3? The reference angle was 30, which was a good thing because we could use the reference triangle or the special triangle to find the ratios. And then we used the x, y, and r values to get the ratios. We did all that right. Given a point, first we plotted the point. We figured out the quadrant where the terminal arm ended. We found the r value using Pythagorean theorem. And then we used the x, y, and r values for the ratios. Finally, we didn't know the angle, but we could calculate it. And we needed to consider the reference angle, but also what quadrant the terminal arm ended in. Great job.
To get stronger at math and to be able to perform in an independent test situation, you really need to vary your practice, space your practice, and challenge your thinking. Once you're finished a set of questions, look them over and ask questions. Write questions in the margin so that you can ask your teacher the next day. It's also useful to redo questions in a different order, and that's what we'll do here. We'll look at the questions this time very quickly, but we'll do only column 1 first, focusing on the angle in standard position, and then we'll move to column 2 and try to see some patterns that will help you when you're working on questions on your own. For column 1, we looked at the angle 120 degrees and plotted it, and we wrote out all of the ratios. Notice that there was one ratio in quadrant 2 that was positive, the sine ratio. We have a mnemonic device here on the right side, and many people remember it by thinking of the phrase, all students take calculus. What it shows you is the positive ratios in each of the quadrants. All of the trig ratios are positive in quadrant 1. Only the sine ratio is positive in quadrant 2. The tangent ratio is the only one positive in quadrant 3. And cosine ratio is the only one positive in quadrant 4. Let's see if this matches up with the other 5 examples. In set 2, the only one positive is tangent, and in set 2 we are in quadrant 3. Quadrant 3 here corresponds to tangent, the only one being positive. In set 3, negative 510 degrees, the only positive ratio was the tangent ratio, and that's in quadrant 3 again, which corresponds to all students take calculus. Looking at the second column, in quadrant 4, the ratio that's positive is the cosine, and that corresponds. In set 2, we're in quadrant 3, and the only positive ratio is the tangent, and that corresponds. And finally, in set 3, we are in quadrant 1, and all of the ratios are positive, and that corresponds with quadrant 1 in all students take calculus. Whether you're given the angle or a point on the terminal arm, be sure to keep the all students take calculus mnemonic device in your mind, but also remember to use the special triangles when you have a 30, 60, or 45 degree reference angle. These tools will help you write the positive or negative ratios faster.